Hey guys, this is Carrie, and this is the answer key video for homework number 5, Unit 7. So we're going to start off this homework set similar to how we started off in class by looking at some evidence for the remainder theorem's truth. So we've got 3 parts, and hopefully they show kind of why, or not why, but an example of the remainder theorem working in action. So determine the quotient or remainder when f of x is divided by g of x. So you've got f of x here, 2x cubed minus 3x squared minus 7. We're going to be dividing that by x minus 3. And of course, when we do a division problem, that will leave us with a quotient. So quotient, that's the thing that we need to determine. So to do it, we're going to convert this from a division problem by multiplying by x minus 3 to a multiplication problem. So that gives us 2x cubed minus 3x squared minus 7 equals x minus 3 times our blue quotient. So figuring this out, we've got, let's see, 2x squared here. X times 2x squared is 2x cubed. That works. But when we put the 2x squared here, that also gives us negative 6x squared. We want negative 3x squared, so we need to have an x term. That next term has got to give us, in combination, negative 3x squared. So it looks like we need to have a positive 3x here, so that when we do x times 3x, it gives us positive 3x squared. That gives us, in total, negative 3x squared. But when we put the negative 3x there, it also gives us a negative 9x. And we do not want a negative 9x. We would like no x's. So in order to get no x's, we need to cancel out our negative 9x with a positive 9x here. To create that positive 9x, we should do x times 9. That is 9x. That gives us no x's. But when we put that positive 9 there, it also gives us negative 27. We don't want negative 27. We want negative 7. So there needs to be an x term. That when we combine it, gives us negative 7. That next term, there's no place for it in the parentheses. So it's got to be our remainder term of positive 20 here. So together, those give us negative 7. So it looks like, identifying things here, we've got our quotient, q of x, and our remainder, r of x. All right, let's see about parts B and C. So for part B, it asks us to find g of 3. This was a typo that hopefully I fixed in your problem set. It should have said f of 3 here. So when we find f of 3, we get f of 3 equals 3 is our input value, so we input it in for x. It gives us 2 times 3 cubed minus 3 times 3 squared minus 7. 3 cubed is 27, so we get 2 times 27 minus 3 times 9 minus 7, 54 minus 27 minus 7. 54 minus 27 is 27. 27 minus 7 is 20. So f of 3 is equal to 20. Okay, this is crazy, guys. Notice that in part C, it's asking us to, notice something about our answers to A and B. The only thing that these share in common is that this value, f of 3 equals 20, is the exact same thing that we got from our remainder. So, same. So for part C, maybe, the remainder, when we divide by x minus 3, is 20, as is f of 3. And this is exactly the remainder theorem. So what the remainder theorem states is, if you have a polynomial, f of x, and you divide it by x minus a, you're going to get a quotient, you're going to get a remainder. This thing, the remainder, is equivalent to f when you plug in the opposite. So if you have x minus a here, the remainder when you divide by x minus a will be f of a. So let's see if I can say that in words. The remainder when you divide by x minus a is, when you divide f of x by x minus a is f of the opposite. So instead of minus a here, it'll be f of a. And this is actually an amazing shortcut that we're going to use to make the next problem incredibly easy. So determine the remainder when this is divided by x minus 2. Now usually you'd have to go through that very long process that we did over here to find the remainder. But because we just want the remainder, we can actually use the remainder theorem. So what the remainder theorem says here is the remainder when f of x is divided by x minus 2 is f of, instead of minus a, the remainder theorem says f of a, so we do f of, instead of minus 2, 2. So to skip the whole division, all we have to do is plug in 2. So we get 2 times 2 to the 5th minus 4 times 2 cubed plus 2 times 2 squared minus 14. You can punch this all in a calculator, but I don't have a calculator, so 2 times 2 to the 5th, that's 64. This is 32 in total. This is 8. This is negative 14. So 64 minus 32 is 32, plus 8 is 40, minus 14 is 26. So because f of 2 equals 26, it implies that the remainder is 26 as well. That's just the remainder theorem. So which of the following functions will have the greatest remainder when it is divided by g of x equals x plus 1? Wow, this problem would be incredibly annoying to do if we had to actually do this division process to find all the remainders. However, we know the remainder theorem, so it's much easier. So in order to figure it out, we'll calculate each of the remainders by using the remainder theorem. So the remainder when we divide by x plus 1, it's going to be the opposite of plus 1. It will be a of negative 1 will tell us the remainder. So a of negative 1 is equal to negative 1 squared minus 4 times negative 1 plus 3. A of negative 1 is equal to negative 1 squared is 1 plus 4. That's 5 plus 3, that's 8. So the remainder is 8 for the first one. For the next one, we do b of negative 1. b of negative 1 is negative 1 cubed plus 3 times negative 1 minus 5. This is negative 1 minus 3 minus 5. B of negative 1 is negative 9. C of negative 1, we plug in negative 1 again, 2 times negative 1 cubed, plus 4 times negative 1 squared, plus 3. Negative 1 cubed is negative 1, this gives us negative 2, plus 4, that's 2, plus 3, that's 5. So it looks like 1 is still the highest at this point. Next up, d of negative 1 is equal to 2 times negative 1 cubed minus 4 times negative 1 plus 1. You don't have to do this math in your head. You can just plug it in all in on a calculator. Don't have a calculator though, so let's see. Negative 1 cubed is negative 1. 2 times negative 1 is negative 2. Plus 4 plus 1, that is 3, which is also less than 8. So it looks like A will have the largest remainder if we do the division. Next up, let f of x be the function below. What is the remainder when f of x is divided by x minus 1? So at first you might think, that's impossible. We don't even know f of x. How would we find the remainder? Well, the way that we find the remainder is this. We use the remainder theorem. When you want the remainder divided by x minus 1, that will be equivalent to f of the opposite, f of 1. To find f of 1, we go to 1 on the x-axis, and we go to 1 on the x-axis, and we go up to the point here, and we get, the point is 1, 4, and that means that f of 1 is 4, so the remainder is 4 as well. I think I have a typo here. Hopefully I've corrected this in your problem set before I gave you this. It should say divide by x minus 5, because if it was x plus 5, it would be impossible. So when we want the remainder divided by x minus 5, we're going to plug in the opposite, which would be f of 5. The opposite of this is, let's see, 1, 2, 3, 4, 5. It looks like that is the point 5, 8. So since f of 5 is 8, the remainder would be 8. All right, for the next one, it looks like you will be able to figure this one out on your own, so I'm going to skip